Greetings everyone. In this video, I'm going to introduce you to a special and unique place where several different types of features from Ice Age megafloods occur together in close proximity. The three megaflood features are 1. Giant current ripples, 2. Ringed dikes and craters, and 3. Flood rhythmites. Two of these features, giant ripples and rhythmites, are depositional in nature, while the third, ringed craters, result from erosion and wearing away of the underlying basalt bedrock during outburst flooding. This area is located near the center of eastern Washington's expansive channeled Scabland, near Sylvan Lake, along Crab Creek Coulee, just one of dozens of megaflood channels. Ringed dikes and craters and basalt bedrock are the oldest geologic feature represented here. Just two of these ring structures are featured here, but dozens of others lie nearby. The rings formed 16 million years ago as the volcanic Rosa basalt flow spread into this area. Most Columbia River basalt flows spread out evenly and are flat-lying, but occasionally we'll see tilted concentric rings or semi-vertical dikes in the basalt. The cause of the ring dikes is not completely understood, but geologists believe they formed as molten lava flowed over pockets of surface water, leading to steam eruptions within the flow. These localized steam eruptions would deform the molten lava, pushing it upward over the steam vents. The lava and dikes quickly cooled and hardened, preserving the ring structures. This ring structure reminds me of a cinnamon roll. Much later, about 2 million years ago, this entire area was subsequently covered by a blanket of wind-blown Palouse loess. Then, starting about 1 to 2 million years ago, Ice Age megafloods locally eroded through the loess into the underlying basalt bedrock. The loess is preserved, however, above and along the sides and in between flood coulees, including Crab Creek. The loess today supports the rich dryland wheat agriculture across eastern Washington, in between areas eroded by megafloods. Within Crab Creek Coulee, however, flood erosion removed the loess, exhuming and eroding into the top of basalt, exposing the ancient ring structures we see today. Another YouTube video named Ring Craters examines further the characteristics and origins of these unusual landforms. Even as megafloods eroded into the basalt bedrock, in places they simultaneously deposited flood sediments, like this megaflood bar adjacent to Sylvan Lake. Notice this gigantic 1 mile long flood bar is covered with continuous series of giant current ripples. Also notice how the parallel mega ripples are asymmetrical, always steeper on the downstream side, indicating the flow direction for the floods was down valley to the west. And finally, notice how megafloods simultaneously eroded down to bare basalt bedrock immediately adjacent to the flood bar, exposing the once buried ring dikes and craters underneath. So what was going on during Ice Age flooding, during the growth and development of this 1 mile long Ice Age flood bar? Well, conveniently, there's an excellent record for flood deposition that occurred within the bar, exposed in a man-made borrow pit. Here is a wonderfully visual record of 20 or more flood pulses preserved within the bar. The Rhythmites are beautifully exposed and preserved within this man-made quarry at the downstream end of the megaflood bar. The history of flooding and water flow is clearly preserved in the details of the Rhythmites. At the bottom of each Rhythmite is an erosional surface created by the initial flood pulse. Above this erosional contact lies a sequence of high-energy, force-head-bedded sand and gravel that transitions upward into finer sand and silt, an indication that flow current waned over time. At the top of each Rhythmite is another erosional surface associated with a high-velocity pulse from the next flood. Within each Rhythmite, coarse sand and gravel at the bottom gradually transition to fine sand and silt at the top, without a break in sedimentation. Notice how the cliff swallows have taken advantage of the relatively loose flood sands and gravels exposed in the cliff face for building their nests. The deposition of each Rhythmite then begins with a high energy pulse of coarse sand and gravel, followed by a gradually waning current that produces only fine sand and silt atop each Rhythmite. In short, this continuous gradation within each Rhythmite records an initial high-energy pulse of water, gradually transitioning upward to slack water conditions like that during the waning stages of flooding. Notice the wavy nature of the contacts between some of the beds. These likely represent older flood ripples, subsequently buried by more recent floods. An alternate, less likely explanation for the Rhythmites is that they are the result of deposition associated with the forward migration of giant current ripples during a single flood or only a few floods. Lastly, at the very top of the exposure is some post-flood sediment, including wind-blown loess and a thin layer of white volcanic ash. The ash, indicated with the red arrows, is most likely from the 1980 eruption of Mount St. Helens. For other examples and locations of Ice Age flood Rhythmites, go to my Missoula Flood Rhythmites video on the Ice Age Floods YouTube channel. Thanks for watching.